The second half of this straight line motion PowerPoint is all some previously released AP questions, and so some of them require a calculator, some of them don't, but I just wanted to show you the ways that you would see this topic on the AP test. So let's do some of these together. It says a particle moves along the x-axis with velocity given by v of t equals 3t squared plus 6t for time t greater than or equal to 0. If the position of the particle at x equals 2 is x equals 2 at time equals 0, what is the position of the particle at t equals 1? So, let's see what they're giving us. They are giving us the velocity function, and they're asking us information about the position function, which means we have to take an integral. Now, remember that we are given this velocity equation, but we're also given this initial condition. They're telling us that when time equals 0, the position is 2. We can use that initial condition to solve for the, to solve for the, oh my gosh, constant of integration. Sorry, I was blanking on the word. The constant of integration, and then we'll have a velocity function. Now, there's two ways to do this, and since this is a non-calculator question, some of you guys might feel more comfortable doing it one way than the other, but in the calculator section, there's ways to significantly cut down on time by not trying to think so much about the in-between steps and just trying to go from start to finish. So I want to show you both ways of doing it just so you can see. Using the position function that we learned in our last video, we said that to find position, so I'm going to call this x, to find the position at 1 second, which is essentially what they're asking us here, find the position of the particle at t equals 1, I would take my initial condition, which is 2. The initial condition is the position, remember, so the position is 2. And I would add in the displacement. So the displacement would be from the time it starts. So they're telling us that at 2, it starts at 0 seconds. So that's why I put a 0 down here, is because my initial condition comes from time equals 0, and it gives me that it starts at a position of 2. 2, how much time has elapsed? And so they want to know how much distance has this traveled in between 0 and 1 second. So in between 0 and 1 second of the velocity function, so of v of t dt. Now, I'm just going to leave that right there because I don't want to go any further with that before I show you the way that it probably makes a little bit more sense logically. I just want to come back to this again later to show you that if this was a calculator question, this is how I would prefer you put it in your calculator because it just will save so much time. Now, the logical way that you guys will probably think of this more often is that the way we did it in the last section. So the integral of the velocity function, 3t squared plus 6t dt. The integral of velocity is position, so that would be x of t. The integral of 3t squared is 3t cubed over 3, which simplifies to t cubed. The integral of 6t is 6t squared over 2, which simplifies to 3t squared, plus c. Now, if I use my initial condition, I can plug in my initial condition. So wherever I see a t, I'm going to plug in 0. Wherever I see a 2, I'm going to plug in the, wherever I see an x, I'll plug in the 2 to say that that was my position at time equals 0. So 2 is equal to 0 cubed plus 3 times 0 squared plus c. Therefore, c is equal to 2. My constant of integration is equal to 2. So my specific position function is x of t equals t cubed plus 3t squared plus 2. And last but not least, sometimes they will just ask you for that. They'll just say, what is the position function? So this would have been the answer in that case. But in this case, they're asking for what is the position of the particle at t equals 1. So if I want to evaluate the position at 1 second, I would just plug in 1 everywhere. That would be 1 cubed plus 3 times 1 squared plus 2. And that's 1 plus 3, which is 4. 4 plus 2, which is 6. So the position would be 6. Now, the reason I wanted to show you both ways is I think that this is the way your brain probably thinks more logically about it, is actually taking the integral and then finding the constant of integration using the initial condition and then plugging in 1 to the position function to figure out where the particle is now. However, this equation will do the exact same thing for you, and I just kind of want to point out the similarities. So this, from the integral from 0 to 1, is essentially telling me how far the particle has traveled in between 0 and 1 of this function. And then adding on where you started, which is 2, will tell you where you are now. If you put this into your calculator with this function for v of t, you'll get 6. And so I just wanted to show it to you this way because in the calculator section, it's so much better to do it this way. And in fact, your calculator won't even take integrals for you. It would give you the numeric integral, but just not the algebraic integral. So, same equation. Notice that this is the position equation. Again, we're taking the initial condition, the displacement between 0 and 1, and then using that to find my new position at 1 second. So, in that case, by the way, the answer choice was B. All right, this is a calculator question. It's number 82. So that means it's a calculator question because anything above 70 is calculator required. It says a particle moves along a straight line with the velocity given by v of t equals this at time t greater than or equal to 0. What is the acceleration of the particle at time t equals 3? So they're giving us the velocity function, and they want to know the acceleration function. I hope that kind of triggers in your head like, hey, wait, that's not the integral of velocity, and you're absolutely right. This is a review of what we did first semester. So it's important for you to be able to differentiate between when am I working with integrals and when am I working with derivatives. And in this example, we're working with derivatives because the acceleration is the derivative of velocity. So essentially, what I need you to do is I think I went too far. There we go. I need you to tell me what the derivative is of this velocity function. So I need to know what v prime of 3 is. So essentially in your calculator, you're going to put this in. I do not need you to calculate this by hand because it's a calculator section. I want you to put this function into your calculator, use the derivative feature to find the derivative and evaluate the derivative at 3 and find out which one of these it equals. So I'll do that now. I'm going to go into y equals, I'm going to put in my equation, 7 minus, parentheses, 1.01 to the power of negative t squared, negative x squared. Alright, then I'm going to go back to my main screen, and I'm going to say, okay, math 8. Remember that math 8 is the derivative option. So you'll say it's the derivative with respect to x, since that's my important variable. Put in y1 for your equation, and then evaluate the derivative at 3, and see what you get. Let me do that now. Comma. I got 0.055, which is answer choice B. So make sure you're able to get that as well. In these videos, if you ever have trouble with your calculator, if I'm not able to pull up the actual screen to see it, when you're having trouble with your calculator, make sure to return to class and ask either the substitute or a peer for help in how to figure this out. All right. Again, another calculator question. It says, an object traveling in a straight line has the position x of t at time t. If the initial position is x sub 0 equals 2, and the velocity of the object is v of t equals this whole thing, what is the position of the object at t equals 3? So, they're giving us velocity, and they're asking us about position. So in your brain, you should be wondering, am I working with derivatives, or am I working with integrals? And the answer in this case is, we're working with integrals, because position is the integral of velocity. Remember that our position function, I'm going to pull up that one I told you guys I want you to use your shortcut with. If I want to know the position at 3, I need to take my initial condition. My initial condition is that when time equals 0, the position is 2. So my initial condition is 2 plus, I want to know how far it went from 0 to 3. So again, notice that the 0 and the 2 pair up. At 0 seconds, the initial condition is 2. It starts at 2 position. And I want to know what's the displacement, how much distance has it traveled, or what's the difference in where it started and where it ended between 0 and 3 seconds of v of t dt. Now, because this is a calculator section, I don't need to put any work into it. I don't need to take the integral by hand. I don't need to do any of that. I want you to get out your calculator. I want you to go to y equals, enter in this equation, the cubed root. Remember, to get to a cubed root, it's math, I think option 4 is the cubed root. And then we're going to put the cubed root of 1 plus x squared, or 1 plus t squared. Then go back to your main screen, and enter it in as exactly like you see here. So enter in 2 plus, and then to recall that integral, remember to go to math 9. Then you're going to put your limits of integration from 0 to 3. Recall the function you just typed in for y1, and then put the important variable as x, and push enter. See what you get. I'm going to do it on my calculator to make sure I get the same answer as you guys. My limits of integration are from 0 to 3. And I get that my final answer is, the position is now at 6.512. Answer choice D. Alright, this is a calculator question again. Maybe not necessarily that you need a calculator, but you're allowed to use one if you wanted to. It says the table gives selected values of the velocity function of a particle moving along the x-axis. At time equals 0, the particle is at the origin. Which of the following could be the graph of the position of the particle for t equals in between 0 and 4? First of all, there's some clues in the directions for us as to which graphs we are able to eliminate, and I hope that you guys caught on to it. They are giving us an initial condition. So they're telling us that at time t equals 0, the particle is at the origin, which means that my position graph should start at 0, 0. If you look at these 5 options down here, 2 of them do not start at 0, 0, and I can eliminate those 2 options. B starts at 0, negative 1, and D, I know it's kind of hard to see on your screen, but D starts at 0, negative 1 as well. So I know that those 2 are able to be eliminated because they do not start at the origin. So now we're down to 3 possible answers. If we look at the velocity values, it says the velocity starts off negative, then changes to positive, positive goes to 0, and then back to negative again. Remember that when velocity is negative, it means that the particle is moving to the left, or down in this case, if we're looking at it in up and down motions. If velocity is positive, it means that the particle is moving to the right. So keep that in mind, is that our function should start off going down, and then it changes to going up, and then it changes back to going down again. So if we look at our graphs, this first one does not start going down. It starts going up and then changes to going down around 2 seconds. But if you look at 2 in our chart, at 2 seconds, the velocity should be 3. It should have a positive slope. But on this graph at 2 seconds, it looks like it has a slope of 0. So I'm thinking A is not the correct answer. For C, it does start going down, and then it starts going up again, and then it starts going down again. So I like that one. I'm a big fan of C, because again, our velocities were negative, and then positive, and then negative. Looking closely at this one, at 3, it says the velocity should be 0, meaning it should have a horizontal tangent line. So if we look over here at 1, 2, 3, and then look up here at this graph, it might not be drawn perfectly, but it looks like that's pretty close to having a horizontal tangent line at 3. Looking at this last one again, I know it's kind of hard to see. It starts going down, then goes up, and then goes down again. Okay. If we look closely at 3, 1, 2, 3, it does look like it has a horizontal tangent line there. So I still think it's a little close to call between C and E based solely on that information. So let's look at one more piece of information, and that last piece of information that's going to help us really identify the answer here is this point right here that I'm highlighting in red. If you look closely at that last point, I want you to notice where it is. So on option C, it's in between 0 and 1. On option E, it doesn't occur until after 1. Okay. So that means that the values should all be negative before, if the correct answer was option E, then all of the values before like 1.5 should all be negative. And on option C, as soon as you pass like, what is this, like 0.8 or something, as soon as you pass 0.8, all of the options are positive again. In this point, maybe I misspoke a little bit. This point isn't as clear as maybe looking at some of the other ones. So I kind of want to highlight a couple points. So I'm looking at these 2 turning points. I know it's kind of hard to see on your screen, because that Doceri desktop trial thing is blocking it. But really I'm looking at, like, is that close enough to 3 to be the turning point for the horizontal tangent line? And then in between 0 and 1, we should have a turning point as well, since we changed from negative to positive values, which is happening here. And I feel like this one just cuts it a little bit close. Like, this one also is close to 3, but this one I think cuts it a little too close to 1. And I don't think that slope is steep enough at 1, where we could say that that one has a slope of 2, units right there at 1. So this isn't my favorite question in the world because these two often trick students and thinking like, this one's not exactly at 3, it doesn't look right, but then this one's not exactly at 2, it doesn't look right. And so I think C is what I lean toward. Please know that on the AP test, they're much, much more clear about that. They don't put two graphs that are so similar with such misleading characteristics. But I'm leaning towards C in the sense that I think it has to have a turning point in between 0 and 1 because it changes from negative to positive slopes. And then again at 3, and I think that's close enough to 3 to the point where it would be answer choice C. On this one, it says a particle moves along the x-axis so that its position is given by that function. At what time t is the particle at rest? Remember that a particle is at rest wherever its velocity is equal to 0. So if I want to find the velocity function, I need to take the derivative. The derivative of this function is, and this is a non-calculator question, by the way, it's 6t squared minus 42t plus 72. If I want to know where it's at rest, I want to know where it's equal to 0. If I divide both sides by 6 to make these numbers a little bit more manageable, I get that t squared minus 7t plus 12 is equal to 0. This factors to t minus 3, t minus 4 equals 0. Therefore, t equals 3 and t equals 4 are the two times when the velocity is 0, which means the particle is not moving, which means it's at rest. Answer choice E. This one is a calculator question, so pull out your calculators again. They are giving us information about the velocity function, and they are asking us information about the acceleration function. Again, this is a derivative. So I want you guys in your calculators to evaluate the derivative, v prime of t, at 4 seconds. So I want to know what v prime of 4 is. I'll give you a minute to put that in your calculators right now, while I do the same. Remember, it's math 8 for derivative. 3 plus 4.1 cosine of 0.9t, or in this case, 0.9x. And we are evaluating the derivative at 4. When I did that, I got the answer of 1.633. Answer choice C. Another calculator question. It says the acceleration is given by this function. If the velocity of the particle is 2 at time t equals 1, then the velocity of the particle at time t equals 2 is blank. Again, the setup of this. So we are given acceleration, asked about velocity. That's going to be an integral. Now, I know this isn't necessarily asking about position, but the formula you can use, or the equation you can use, is the same as that one we use for position, where we say the velocity at 2 seconds must be equal to the initial condition. And they're telling us that the initial condition is that at 2 seconds, at 1 second, the velocity is 2. So my initial condition is 2, and that started at 1 second. So remember that these two go together. At 1 second, my initial condition about velocity is that it started with a velocity of 2. And then I want to know how much velocity has accumulated in between 1 second and what I'm trying to find out, which is 2 seconds. Of this acceleration function, a of t dt. Now, I write this out, by the way, because if they ever ask this question in a free response section, this would be the work that they would expect you to put, and then as long as you have the answer after that, it's fine. You can't put the answer alone, like you can't figure it out your own way and then just put an answer. If you're going to figure it out a different way, you have to actually show the steps that you took in order to come up with an answer, but this is enough work, or a sufficient amount of work, in order to get credit for this question. So to go through it one more time, the integral of the acceleration from 1 to 2 is going to tell me how much velocity has accumulated in between 1 and 2 seconds. And then when we add that to the initial velocity, it will tell us what the velocity is now at 2 seconds. So I'm going to give you a minute to put that in your calculator while I put it in mine, and then we'll come back together again and compare answers. For y1, we have ln of 1 plus 2 to the t, or 2 to the x. Go back to your main screen. Math 9 is the integral. So I'm going to do 2 plus math 9. And put your limits of integration, and put the y1 function, dx, and then evaluate. I got 3.346. Answer choice E. So that's what I got for my initial velocity at 2 seconds. All right. And that's the last one for today. Perfect.